Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.
We're asked to find the square root of 100. Let me write this down bigger. So the square root is this big check looking thing. The square root of 100. And when you see it like this means the positive square root. If you're familiar with negative numbers, you know that there's also a negative square root. But when you just see this symbol, that means the positive square root. So let's think about what this is saying. This is asking us find the number, the positive number, that when I multiply that number by itself, I get 100. So what number when I multiply by itself do I get 100? Let's see. If I multiply 9 by itself, that's only going to be 81. If I multiply 10 by itself, that is 100. So this is equal to, and let me write it this way. Normally you could skip this step, but you could write this as the square root of, and instead of 100, 100 is the same thing as 10 times 10. And then you know the square root of something times itself, that's just going to be that something. This is just equal to 10. So the square root of 100 is 10. Or another way you could write, I guess, the same truth is that 10 squared, which is equal to 10 times 10, is equal to 100.
Root of 100. I want to talk to you for a second about perfect squares. So perfect squares are when you can take a whole number or basically just integers, a positive or a negative number, okay? And you can multiply them by themselves, so square them, and you get the result of that is a perfect square. If you multiply decimals together, your result would not be a perfect square. So for instance, the first one would be 1 squared equals 1 times 1, which is 1. The second one would be 2 squared, which would be 2 times 2, which is 4. The third one, 3 squared is 3 times 3, which is 9. Then we have 4 squared, 4 times 4 equals 16. And 5 squared equals 5 times 5 equals 25. So I would like for you to go ahead and find the next set of perfect squares. You should get 6 times 6 equals 36. 7 squared equals 7 times 7 equals 49. 8 squared equals 8 times 8 equals 64. 9 squared equals 9 times 9 equals 81. And 10 squared equals 10 times 10 equals 100. Make sure that you're writing that second step in there so that you can remember you're squaring the number by itself, or you're multiplying the number by itself. Go ahead and find the third step, or the third set of these. You should get 11 squared equals 11 times 11 equals 121. 12 squared equals 12 times 12 equals 144. 13 squared equals 13 times 13, which equals 169. 14 squared equals 14 times 14, which equals 196. 15 squared equals 15 times 15 equals 225. And the last set, 16 squared equals 16 times 16, which equals 256. 17 squared equals 17 times 17, which equals 289. 18 squared equals 18 times 18, which equals 324. 19 squared equals 19 times 19, which equals 361. And 20 squared equals 20 times 20, which equals 400. Now that you have this list, it will come in handy because on your foldable it asks you to find the square root of 121, to find the square root of 169, to find the square root of 9, and to find the square root of 1. So go ahead and do that.
Right over here. So square root of 45. So the square root of 45, or the principal root of 45. 45 is not a perfect square. It's definitely not a perfect square. But we know, let's see, what are the perfect squares around it? We know that it is going to be less than, the next perfect square above 45 is going to be, let's see, it'll be 49, because that is 7 times 7. So it's less than the square root of 49. and it's greater than the square root of 36. And so the square root of 36, the principal root of 36, I should say, is 6, and the principal root of 49 is 7. So this value right over here is going to be between 6 and 7. And if we look at it, it's only 4 away from 49, and it's 9 away from 36. So it looks like, so the difference between 36 and 49 is it's 13. So it's a total 13 gap between the 6 squared and 7 squared. And this is 9 of the way through it. So just as a kind of approximation, maybe, and it's not going to work out perfectly because we're squaring it. This isn't a linear relationship. But it's going to be closer to 7 than it's going to be to 6. And at least the square of, or the 45 is 9/13 of the way. So we could try, let's see, it looks like well, that's about 2/3 of the way. So let's try 6.7. Let's try 6.7 as a guess, just based on 0.7 is about 2/3. It looks like about the same. Actually, we could calculate this right here if we want. Actually, let's do that just for fun. So 9/13 as a decimal is going to be what? It's going to be, so you get, it's about 0.69. So 6.7 would be a pretty good guess. This is 0.69 of the way between 36 and 49. So let's go roughly 0.69 of the way between 6 and 7. So this is, once again, just to approximate. It's not necessarily going to give us the exact answer. We have to use that as to make a good initial guess and then see how well it works. So let's try 6.7. Let's try 6.7. And the really way to try it is to square 6.7. So 6.7 times 6. Maybe I'll write the multiplication symbol there. 6.7 times 6.7. So this gives us 44.89. So 6.7 gets us pretty close, but we're still not probably right to the hundredth. Well, it's definitely not to the hundredths place. We've only gone to the tenths place right over here. So if we want to get to 45, this 6.7 squared is still less than the square root, or I should say 6.7 squared is still less than 45, or 6.7 is still less than the square root of 45. So let's try 6.71. So let's try let me do this in a new color. I'll do 6.71 in pink. So let's try 6.71. Increase it a little bit. See if we can go from 44.89 to 45, because this is really close already. And if this is, well, let's just try it out. 6.71. So once again, we have to do some arithmetic by hand. So when we squared 6.71, 6.71 squared is equal to 45.0241. So 6.71 is a little bit greater. So let me make it clear now. We know that 6.7 is less than the square root of 45. And we know that that is less than 6.71. Because when we square this, we get something a little bit over the square root of 45. But the key here is when we squared this. So 6.7 squared. So 6.7 squared got us 44.89, which is 11 hundredths away from 45. So this is, and then if we look at 6.71 squared, we're only 2.4 hundredths above 45. So this right here is closer to the square root of 45. So if we approximate to the hundredths place, definitely want to go with 6.71.
Okay, now that you have seen him work with the square root of 45, we're going to take a look at the steps that he used for approximating square roots. So the first thing you have to do is find a perfect square below the number that is given. Remember, he found the square root of 36 because it was below the square root of 45. The second thing you do is to find a perfect square above the square root that you were given. And he used the square root of 49. Then he did some very quick mental math and estimated a fraction. Once you get your fraction, you need to estimate the decimal value of that fraction. And then you test your square root by multiplying. You see, how close did you get to that original number that you wanted? And finally, you need to repeat until you get the best estimate. In his directions, it was asking for the hundredths place, meaning 2 decimal points. So always make sure that you're paying attention to those details.